Have you ever started a small project that just completely snowballed into something way bigger? Well, today we're diving into a story just like that. It all starts with a simple puddle of water and ends with learning chemistry and even how to weld plastic. It's one of those classic DIY journeys, full of frustration, a ton of discovery, and that awesome satisfaction of a job well done.
Okay, so let's start with a real head scratcher. Your vehicle, it hasn't moved an inch in over a week. It hasn't rained, but you open the door and there it is, a puddle on the floor. Where on earth could that water be coming from? This is the little mystery that kicks off this entire adventure. So, the whole investigation kicks off with that simple, baffling discovery. There's a pool of water in the passenger footwell of this Polaris Ranger. But the weird part, the vehicle had just been sitting there, totally untouched, for more than a week. Makes no sense, right?
Now, your first suspect is probably the windshield seal, right? I mean, that's a classic culprit for leaks. But the thing is, for a vehicle that's just been sitting, the evidence didn't really add up. The real clue came from looking up. The headliner, right above the puddle, was completely soaked, so the problem wasn't coming from the front at all. It was coming from directly overhead. Well, with the search now focused on the roof, there was only one thing to do: climb up and have a look. And that's when the source of this whole mysterious leak became, well, painfully obvious.
And yep, there's our culprit. A long, skinny hairline crack running right along the roof's surface. After a few days of heavy rain, that tiny little fracture basically turned into a funnel. The most likely cause? A run-in with a stray tree branch on an off-road trip. A classic battle scar for a machine like this.
What's really interesting here is that the crack's location wasn't random at all. If you look at the image on the right, you can see one of the mounting clips that holds the roof to the vehicle's frame. The crack, on the left, formed right above it. This is a natural stress point. So when that tree branch snagged the roof, this is exactly where it decided to give way. So to really see what was going on and figure out a repair, the whole roof had to come off. And here we go. This is a classic DIY moment, isn't it? You start one job and you immediately find another. As the roof lining was getting pulled off, about 95% of the owner-installed soundproofing material, which had been glued on about 18 months earlier, just fell off. So now we've got two problems to solve: a cracked roof and a bunch of failed soundproofing. This was a real decision point. And for a true DIYer, the choice wasn't just to fix it, but to learn a completely new skill while doing it. When you look at the options, buying a brand new roof was going to be the most expensive, for sure. Hiring a pro? Well, you have less control over the whole thing. But the DIY plastic weld? Hey, that was a chance to learn something new, save some serious cash, and really understand the vehicle better. The choice was pretty clear. Of course, the DIY path is rarely a straight line, is it? The specialized heat gun and the plastic welding rods were ordered, but then crickets. Shipping and stock issues brought the whole project to a grinding halt for almost 4 weeks. So frustrating. But hey, that's a very real part of any project these days. Okay, with the tools finally in hand, it was time to get to work. After a couple of practice runs on some scrap plastic, the actual repair could begin. And it's a pretty methodical 4-step approach that's all about creating the strongest possible bond. So, here's a really crucial point: preparation. You can't just melt some plastic over the top of the crack and call it a day. Using a Dremel tool, the crack was carefully ground out into this V-shaped groove. This is a brilliant illustration of a core principle of welding. You have to maximize the surface area so the new material can really fuse with the old. And here is where the magic happens. With the heat gun set to the perfect melting temperature for this specific HDP plastic, the welding rod is fed right into that V-groove. The goal is to melt both the rod and the edges of the groove at the same time, letting them mix together and fuse into one solid piece of plastic as it all cools down. And here's the payoff. On the left, that's the problem we started with. And on the right, the finished weld. Look, it may not win any beauty contests, but it is strong, it's solid, and most importantly, it is completely watertight. A functional repair that saved a ton of money on a replacement. That is a definite win. So, with the leak officially fixed, it was time to circle back and deal with that second problem. But this wasn't just about sticking the soundproofing back on, it was about understanding why it failed in the first place, to make absolutely sure it never, ever happened again. The original glue just completely gave up, and the reason is pure chemistry. See, the roof is made of something called high-density polyethylene, or HDPE. It's a fantastic material. It's tough, it's flexible, but it's also incredibly slick on a microscopic level. It's kind of like trying to glue something to a Teflon pan. Adhesives just have almost nothing to grab onto. So how in the world do you glue the ungluable? Well, this is where it gets really, really cool. The answer is a fascinating process called flame activation. By quickly passing a flame over the plastic, you're not actually melting it, you're causing a chemical reaction right on the surface. This reaction basically roughs up the super slick plastic on a molecular level, giving the adhesive something to finally grip onto. Now, this little chemical trick is just one part of a full-on bonding procedure. First, you've got to scuff the surface with sandpaper to create a physical grip. Then it's cleaned meticulously. Only then do you do the flame activation, right before a strong spray adhesive is applied to both the roof and the soundproofing for a permanent bond. And just when it seemed like things were going smoothly, another little discovery. While prepping the other side of the roof for its soundproofing, a second, much smaller hairline crack was found near the opposite mounting clip. A little bit of a setback, but hey, it was caught and welded before it could turn into a bigger problem down the road. All right, deep breath. Both cracks are welded solid, the soundproofing is secure and not going anywhere, and the roof is finally ready to go back on the vehicle. This is the home stretch. We're almost there. So the roof is bolted on, all the wiring is reconnected, and it's time for the moment of truth. The key turns, the engine fires up, and... you have got to be kidding me. One last twist. 2 error codes pop up on the dash, one for the gas pedal sensor, and another for the brake pressure sensor. After all that work, an electronic gremlin decides to show up. Just as your heart sinks and you start thinking about complicated sensor diagnostics, the solution turns out to be, well, shockingly simple. Turns out these are pretty common codes on this vehicle after the battery has been disconnected. All it took was one firm press all the way down on the gas pedal, followed by one firm press on the brake pedal, and poof, the codes vanished. The system just needed to recalibrate itself. And there we have it. After almost 2 months of diagnosing, waiting on parts, learning brand new skills, and fighting through unexpected setbacks, the Polaris is finally whole again. The roof is completely watertight, the interior is quiet, and it is ready to get back out on the trails where it belongs.